Hello, you're welcome to today's chemistry class. And today we will be talking about calculations on gas laws. Yes, calculations on gas laws. So by the end of this video, you'll be able to carry out calculations on gas laws regardless of the way it is structured or whatever way it is designed. Now, I want you to understand that this is going the topic gas laws would actually be discussed in two different videos. Yes, because we can't cover it in one stretch. So, because there are so many gas laws, so we'll be actually talking about gas laws in two sections. But in this particular video, we'll be talking about Charles' law, Boyle's law, and the combined gas laws, which is otherwise known as the general gas law. So the first video, which is this one here, which is the part one of gas laws, it will be talking about these three. Then the next video will be talking about Graham's law of diffusion. We'll be talking about the ideal gas law. We'll be talking about all other laws, Dalton's law of partial pressure, and all the rest. So this is the first section. So let's go ahead and begin. Let's start with Charles' law. So Charles' law actually states that the volume of a given mass of gas is directly proportional to its absolute temperature, provided that the pressure is kept constant. I repeat, the volume of a given mass of gas is directly proportional to its absolute temperature, provided that the pressure is kept constant. So now we have this in mind. Let's talk about the mathematical representation of this law. So we have this as V is directly proportional to T. Now, that is the volume of a given mass of gas directly proportional to temperature. Now, please, I want you to bear in mind that when we mean the absolute temperature, we mean the temperature in Kelvin. Please, the representation of our temperature has to be in Kelvin. So when you are carrying out any gas law at all, please bear in mind any calculations on gas laws, your temperature must be converted in Kelvin, because the way students get it all wrong is when we have our temperature remaining in Celsius, not converted to Kelvin. Now, how do you convert your temperature to Kelvin? Please bear in mind that your temperature is converted to Kelvin when you add whatever temperature given in Celsius and you add it to 273 Kelvin. So I mean, if you are given 0 degrees Celsius, you have to add it to 273 Kelvin, so which is what? 273 Kelvin. If you're given 10 degrees Celsius, it has to be added to 273 Kelvin, which gives you 283 Kelvin. Literally, this is how you carry out your conversions from Celsius to Kelvin. You add whatever figure is given to you and you add it to 273 Kelvin. Yes, and that gives you 283 for this one 10, and this one is 273. Now we have this in mind. We have to come back to this, because when you have V is directly proportional to T, this can also be written as V is equals to KT. Yes, V is equals to KT, and we can have our K given as V over T. And in a case where we have multiple volumes or multiple temperatures, you have the equation given as V1 over T1 equals to V2 over T2. Now that begs the question, what is V1? V1 stands for the initial volume, and T1 stands for the initial temperature, V2 stands for the new volume, and T2 stands for the new temperature. When you have this in mind, whatever parameter is missing, you can insert it inside here and make it the subject of formula, and you carry out your calculation. It's that easy. It's that easy. It's not even difficult at all. Now we have this analyzed. Let us actually carry out an example so it makes more sense to you the way the calculation is being carried out. So let's go. Now let's take a look at this question. 50 centimeter cube of gas at 17 degrees Celsius is cooled to 7 degrees Celsius. At constant pressure, what is the new volume of the gas? Now, one thing you should bear in mind is you should actually write out your parameters first. When you write out your parameters, it gives you a clearer perspective of what you're looking for and the formula to apply and the missing parameter. So Let us let us write it out. Now the question here is 50 centimeter cube of a gas at 17 degrees Celsius. So that means V1 is 50 centimeter cube. 50 centimeter cube. Then the next question is at 17 degrees Celsius, the next parameter, at 17 degrees Celsius, that means our T1 is what? 17 degrees Celsius. Is equal to 7 degrees Celsius. So you have your T2 at 7 degrees Celsius. Now, when you have your T2 at 7 degrees Celsius, then they ask what is the new volume. So that means we don't have a V2. So since we don't have a V2, so the question is, what do? We have to apply our Charles law formula, which is V1 over T1 equals to V2 over T2. But but we need to carry out our conversions first. Now, what's the conversion like? We have to, before you carry out, how to carry out a conversion is you have to add 273 Kelvin. Before you carry out any calculation on gas laws, please and please bear in mind that you must add 273 Kelvin to whatever temperature that is given as far as it is given in Celsius. So this particular question is actually given in Celsius. Hence, we have to add 273. These two will have 273, and in total, this will give you 290 Kelvin, and this will give you 280 Kelvin. Now we have this, we can now proceed. So you have something like V1 over T1 equals to V2 over T2. Now, what's our V1 here? V1 is giving us 50 centimeter cube. T1 is giving us 290, and our V2 is giving us the unknown. That's what we are looking for, and our T2 is 280. Now we can cross multiply to make our V2 subject of formula. So you have 50 times 280 over before I put over, equals to 290 V2. Now we have this, then we can now make our V2 subject of formula by dividing both sides by 290. And when you have that, you have 48.28 centimeter cube. That is your new volume. Now, this is literally how to carry out your conversions, your calculations, and whatever as regards Charles law. So as far as you have volume and temperature given and the pressure is constant, please know that the formula you have to apply is V1 over T1 equals to V2 over T2. As far as the pressure does not change, as far as the pressure remains the same, you are working with the gas equation, which is V1 over T1 equals to V2 over T2. Now we have stated this. Now let us proceed to the next one, which is Boyle's law. All right, let's go. Now, for Boyle's law actually states that the volume of a given mass of gas is inversely proportional to its pressure provided that the temperature is kept constant. Yes, the volume of a given mass of gas is inversely proportional to its pressure provided that the temperature is kept constant. So in this case, our V is inversely proportional to our P. Now, we have a representation as V, which stands for our volume, inversely proportional to what? Our pressure. Now, when you have this can be written as V is equals to K over P. And when you have V equals to K over P, you cross multiply and you have K is equals to PV. Now, in a case where we have multiple pressure and multiple volumes, you have P1 V1 equals to P2 V2. P1 V1 is equals to P2 V2. Now, the question should be, what do they mean? Your P1 stands for initial pressure, your V1 stands for initial volume, your P2 stands for initial the new pressure, and your V2 stands for the new volume. Now, when you have this is easy to carry out calculations, because as far as there is no new temperature, this is what you are working with. So now we have this, let us carry out our calculations. Okay, now let's take a look at this particular question. Now you start. Now the pressure of 100 centimeter cube of oxygen gas at 35 degrees Celsius is 715 millimeter mercury. Now, what would be the volume of the gas if the pressure is increased to 100 millimeter mercury without change in the temperature? Without change in the temperature. Now, let's first of all write out the parameters. Let's first of all write out the parameters. Now, the first parameter you're going to see here is 100 centimeter cube of oxygen. So that means our first volume here, which is our V1 happens to be 100 centimeter cube. Okay, what's the next thing? They said gas at 35 degrees Celsius. They said the pressure of 100 centimeter cube of gas at 35 degrees Celsius is 715 millimeter mercury. What would be the volume of the gas? What would be the volume of the gas? Okay, so let's look at the next parameter given here, which is what? 750 millimeter mercury. So that means our P1 is 750 millimeter mercury. Okay, now the next one. What would be the volume of the gas? So that means we are looking for a V2. We do not have a V2. Okay, what would be the volume of the gas if the pressure is increased to 100 millimeter mercury? Yes, so that means we have a P2 which is 100 mmHg. Now, you might wonder why I didn't write my 35 degrees Celsius, because they said it does not change. There is no change in temperature. Hence, we do not need this T1. We do not need this T at all. What we need is our P1 V1, P2 V2. We are working with Boyle's law. Yes, anytime you have a constant temperature, we do not need to insert it in that question. We just work with Boyle's law, because Boyle's law says that the volume of a given mass of gas is inversely proportional to its pressure, provided that the temperature is kept constant. So as far as the temperature is kept constant, we can work with Boyle's law. And what's the formula we are going to work with? P1 V1 equals to P2 V2. P1 V1 equals to P2 V2. Now let's insert it. If you insert this, you have 750 times our V1 here is 100. And what about P2? Our P2 is 100 here. And what about our V2? Our V2 is unknown. That's what we are looking for. So it becomes V2. Now, what's the next thing we do? We make our V2 the subject of formula. So we divide both sides by 100. Divide both sides by 100. And when you divide both sides by 100, what do you have? You have this cancelling out this. So that means, and this cancelling out this. So your V2 is 750 centimeter cube. This is actually how to carry out your calculations as regards Boyle's law. As regards Boyle's law, as far as the temperature is kept constant, any of the missing parameters, be it the volume or the pressure, you can insert it into the inside your formula, and you would get your answer that is required. So this is actually how to carry out Boyle's law calculations. It is dealing with pressure and volume particularly, not with addition of temperature. Not with addition of temperature. So this is it. Now let us get to combined gas law. Now, when it comes to combined gas law, we are going to be talking about both combination of both Charles law and Boyle's law together. So let's go. Let's talk about the combined gas laws. Now, for combined gas laws, we'll be talking about the combination of Boyle's law and Charles law. Yes, the combination of Boyle's law and Charles law. Now, how is it represented? It's represented as P1 V1 over T1 equals to P2 V2 over T2. P1 V1 over T1 equals to P2 V2 over T2. Now, what's your P1? P1 is what? Your initial pressure, initial volume. T1 stands for initial temperature. Remember, V1 stands for initial volume. P2 stands for the new pressure. V2 stands for the new volume, and T2 stands for the new temperature. But one more thing we must talk about is what we call STP. Now, what's STP? STP stands for standard temperature and pressure.
standard temperature and pressure. Now, what does STP mean? STP, the ST, which is the standard temperature, is given as 273 Kelvin. Now, what about the standard pressure? Now, this is the standard temperature. This is standard temperature. But let's talk about standard pressure, which is, we'll call our SP, we'll abbreviate it as SP. But for standard pressure, it has multiple values. Please, I would need you to pay cognizance to this. It has different values depending on the unit that is given. So when you have to carry out your calculation, you have to pay attention to what value is given, so you would know what value to represent it with. Now, what are the different values we have? We have 1.01 times 10 raised to the power 5 Newton per meter square. We have it represented as 760 millimeter mercury. We have it represented as 1.0. We have written that. We have it represented as 1.0 atmosphere. It can be written as any of this. It can even be written as 76. It can also be written as 76 centimeter mercury. It depends on whatever way your question is structured. Now, whatever way it is structured, please pay attention to these units. So the unit that is given tells you or determines the way which question you're working with. So when they say at standard temperature and pressure, we already know that the standard temperature is 273 Kelvin. But at the standard pressure, it can be any of these four given depending on how the question is structured. Now, this might not make sense to you, but now let's carry out a question. Let's carry out a calculation question here so it will make more sense to you. So now let's go. Okay. Now let's take a look at this question. If a gas occupies a container of volume 250 centimeter cube at 12 degrees Celsius and 700 millimeter mercury, finds the volume at STP. So how do we carry out this calculation? The first thing you have to do is write out the parameters. Write out the parameters. As I said, if you write out the parameters, it makes it easy for you to know what is missing, the formula to apply. Now let's start. If a gas occupies a container of volume 250 centimeter cube, that means our volume in this case is 250 centimeter cube, which is our initial volume, the previous volume. Now, at 12 degrees Celsius, so you have your T1 as 12 degrees Celsius. Now remember, you have to convert it to Kelvin. I keep saying it, I reiterate it every moment. As far as you're carrying out a calculation on gases, your temperature must be converted to Kelvin. So you have 12 plus 273, and this gives you 285 Kelvin. Now, after you have this, then the next thing you have to look at is the pressure given, which is 700 millimeter mercury. 700 millimeter mercury. So our P1 in this case is 700 millimeter mercury. So they said find the volume at STP. So if you're looking for the volume at STP, well, how would you go about it? First thing is, what is your STP? Your STP is your standard temperature and pressure. Now remember, your standard temperature is given as 273 Kelvin. So if it is 273 Kelvin, this means that your T2 in this case, because that becomes your new temperature. So your T2 is going to be given as 273 Kelvin. Now, what's going to be your P2, which is your new pressure, which is your standard pressure? Your STP, remember they say standard temperature and pressure. So what is going to be your standard pressure? Now your standard pressure is going to be dependent on the units here, which is 700 millimeter mercury. 700 millimeter mercury. What is going to be the standard pressure here? It's going to be 760, because you have different values for the standard pressure. We have 1 atmosphere, we have 760 millimeter mercury, we have 1.01 times 10 raised to power 5 Newton per meter square, and we also have 76 centimeter mercury. Now, of these values I just mentioned, the only one that has the aligning unit with my P1, which is our pressure, is 760 millimeter mercury. Hence, we are going to be working with 760 millimeter mercury. That means our P2 in this case will be 760 millimeter mercury. Now I have this, I can now apply my formula. Remember, what we are looking for here is our V2. So I can apply my formula as P1 V1 over T1 equals to P2 V2 over T2, because this is what we call the general gas law, or combined gas law. So P1 V1 equals to P2 V2 over T2. So what's our P1? Our P1, as we have here, is 700. So we have 700. And what about our V1? Our V1 is 250. Now what about our T1, which is 285? Now, what about our P2? Our P2 is 760, and our V2 is unknown, so we have to represent it as V2. And what about our T1? Our T2, which is our standard temperature here, is 273. Now we've written all these things. The next thing is to make our V2 the subject of formula by cross multiplying. And when you carry out your cross multiplication, you have this as 700 times 250 times 273. That's for this. Now, for this, you have 285 times 760 times V2. Now, we make our V2 subject of formula by dividing all through by what is here. So you have 285 times 760. 285 times 760. Now, when this cancels out itself, now what figure are you going to have here? The answer you're going to have is 200.57 centimeter cube. And this is the value. This is the value you get for the new volume. So this is how to carry out calculations on general gas laws. This is how you carry out calculation on general gas laws. Now, let us attempt one more question. Okay, one more question on this, on general gas laws, for a better clarification. Let's proceed. Okay, let's have a look at this question. 30 centimeter cube of a gas was collected over water at 27 degrees Celsius and 780 millimeter mercury. If the vapor pressure of water at 27 degrees Celsius is 100 millimeter mercury, calculate the volume of the gas at 760 millimeter mercury and 7 degrees Celsius. And 7 degrees Celsius. So what's the first thing you're going to do? You write out your parameters. Now, when you write out your parameters, then you know what parameter to look for and how to apply it on your equation. Now, let's start. The first thing that was given here was 30 centimeter cube of a gas. So that means your V1 is 30 centimeter cube. Now, what about this? They said it was collected over water at 27 degrees Celsius. So that means your T1 in this case is 27 degrees Celsius. Now remember that your temperature must be converted to what? To Kelvin. So you have plus 273, which is 300 Kelvin. What's the next one? They said and 780 millimeter mercury. So that means our pressure in this case, our initial pressure here is 780 millimeter mercury. Okay, what's the next thing? We have another question here. If the vapor pressure of water at 27 degrees Celsius is 10 millimeter mercury, so our vapor pressure is 10 millimeter mercury. We'll still come to this. I will give a narration on how to go about it. Then calculate the volume of the gas at 760 millimeter mercury. So our next pressure, the new pressure, is 760 and 7 degrees Celsius. That means our T2 here is 7 degrees Celsius plus 273. Always remember that. plus 273, because you're adding this. You have to convert it to Kelvin. Anytime your temperature is in Celsius, it must be converted to Kelvin. So you have 280 Kelvin. So when we have this, before you carry out your calculation, please, in this particular question, anytime they tell you a vapor pressure is given, anytime a vapor pressure is given, that you have to subtract it from whatever pressure that was given at that particular temperature. Look at, they said at 27 degrees Celsius, it was 10 millimeter mercury. That was the vapor pressure. Please bear in mind that at that particular temperature, the pressure that was given was 780. So please, you do not carry out your calculation with 780. You must first of all subtract from the vapor pressure before you carry out your calculation. So what is the your P1 now? In this case, your P1 has to be 780 minus 10, which gives you 770 millimeter mercury. Now you have this, you can now carry out your calculations. You can now carry out your calculations by inserting it into the formula, which is P1 V1 over T1 equals to P2 V2 over T2. Now, let's start. Now, with this, now our P1 is 770 times, what's our V1 now? Our V1 is given us 30. Our T1 is given us 300. And what about our P2? Our P2 was given as 760. What about our V2? Now remember, our V2 is what we are looking for. That's what we are looking for. So it becomes V2, we still represent it as V2. Now what about our T2? Our T2, which is our new temperature, is giving us 280 Kelvin. So when we have this, we can now cross multiply, and when you carry out your cross multiplication, you have 770 times 30 times 280 is equals to, now when you cross this again, you have 300 times 760 times V2. So when you have that, we can now carry out further divisions. Divide this side by all contents that you have here. So you have 300 times 760. This is also 300 times 760, just to cancel out this figure here. So when you carry out your calculation, your answer will be V2 is equal to 28.4 centimeter cube. That is how to carry out your calculations. So this is where we will draw the curtain on gas laws for this video. But please bear in mind that we would have another video released on gas laws 2. We would have the second video, and this particular one will be talking about Graham's law, Charles' law, Graham's law of diffusion, Dalton's law of partial pressure, ideal gas equation, and every other thing that has to do with gas laws in terms of calculations. We will be carrying out calculations on those things. That will be in the next video. But I hope you've enjoyed this video, and I hope you've been enlightened and you've been educated. So this is me appealing that you like, you share, and you subscribe to this channel to get more educative content as regards learning. Thank you very much, and this is where I would call it an end to the video. Thank you very much for watching. See you in the next video. Bye-bye.